Hello everybody, and welcome to Correlations in SPSS. First thing, as always, open up your data set, same one we've been using before, double check it, make sure everything is good. So, correlations, we're going to just kind of jump into correlations unlike some of what we have done previously, because it's going to take a little bit more understanding, a little bit more explanation. Also point out, I think that the correlation PDF, correlation in SPSS PDF that I provided you, is probably going to be even more valuable in this lecture than the other ones. So make sure you've got that up, follow along with that if you would like. So for people who haven't got to correlation yet by hand, correlations really just tell you if there's a linear relationship between two variables. That's kind of the basis of what it is. Is there a linear relationship? It doesn't tell us if one thing causes another, but it does tell us if there is this statistical association between two variables. Now, the first thing that we've got to do is make sure we know what type of variables can be used in correlations. And this gets back to our forever long discussion of nominal versus continuous variables. Now, while you can do a correlation between certain types of nominal variables and continuous variables, for our purposes, we are only doing it between two continuous variables. Only continuous variables here. So to do correlations, at least how we are going to be doing them, we're going to do analyze, correlate, and bivariate. These other kinds of correlations we're not getting into. We're just doing bivariate correlations. And just as we've seen many times before, we have our box pop up, and you can select any of the variables that we have to put over here. But we are only doing continuous variables. So let's start off with happiness, and you'll notice you can't hit OK, because you can't do a correlation between one variable and itself. That's just not a thing that we do. So you need at least two variables. So let's do happiness and how much you like the university. Select those two. And for now, we're just going to hit OK. And up in our output viewer, our statistics viewer, we are going to see this. Now, I have many annotations in your correlation table that will help you out. But let's go through it here as well. So, for your correlation table, what really is important is each of the cells involved. And a cell contains a Pearson correlation, the significance, and the n. And correlation tables, each cell has information about the correlation between whatever the variable in the column is and whatever the variable in the row is. So this first cell is going to be the correlation between happiness and happiness. That's a correlation of 1. That makes complete sense. Any variable correlated with itself is 1. No point in even doing the statistics. This cell down here, where the Pearson correlation is 0.277, significance is 0, and the n is 1628, that is the correlation between happiness and how much you like UM. This cell here, 0.277, significance of 0, n of 1628, is the correlation between how much you like UM and how happy you are. And you'll notice that this cell and this cell are exactly the same, as they should be, because the correlation between happiness and how much you like UM is the same as the correlation of how much you like UM and happiness. So this is what we mean by correlation tables being symmetrical along the diagonal. What that means is that the information as you go down the diagonal for as long as the correlation table goes, you're going to have the same information on the top half of the diagonal as the bottom half of the diagonal. So you're basically going to get half the information, at least, is going to be redundant. All right, so that's the first thing. Second thing is, along the diagonal, you will always have ones. When we add in a third variable, you will see that you're going to get ones down there as well. Actually, why don't we just do that now, and I'll show you. If we go back to correlate and bivariate, let's add in another variable. And we can see that we have a 1 in this cell, 1 in this cell, and a 1 in this cell. And as I said before, all of these values are symmetrical along the diagonal. So 2.77, 2.77, 2.36, 2.36, 0.56, 0.56. Makes sense. That's how it should be. Might look a little weird, but that's just how correlation tables go. All right. So now let's just talk about what each of the three parts are in a little bit more detail. So in any one of the cells, we have our Pearson correlation. That correlation is the same value you would get if you calculated your correlation by hand. It has all the same properties, the correlations we are doing, the same properties as the correlations that we did by hand. So this value will always be between -1 and +1. What this tells us here is that this correlation will be rounding 0.28. That is, that's a small to moderate correlation. The second thing that we can see is the significance. And this significance value is interpreted the same way all the other significance values have. So if it is less than 0.05, it is significant. So now we see that this 0.28 correlation is significant. Therefore, there is a significant linear relationship between those two variables. Any value here less than 0.05 means that this correlation is significant. And then the last one is the n. And that, just like other n's, tells you the number of individuals involved in this correlation. Now, you'll also notice that there are these stars. And these stars are noted on the bottom of the table. 1 star means that the correlation is significant at 0.05. So this right here, our p-value is 0.02. This means that this value is less than 0.05. 2 stars, on the other hand, indicates that the value is less than 0.01. Now, you would actually report them slightly differently if you were to report them for a paper, but this is just how SPSS denotes for kind of quick ease of perusing what the values of the correlations are. All right, so this is basically it for correlation. We will not go over correlation significance by hand. We're not going to be looking at those tables. It gets into a little bit too much complication for what we are here for. But if you're able to run one of these correlation tables, you're able to interpret it. It should be good to go. Now, the last thing that we're going to do for correlation is I'm going to show you how to make a scatter plot. And if you remember back to the lecture, or if you haven't got there yet, you'll see when we get to the correlation lecture that this is actually a really good way to visualize correlations. So if we do graphs and chart builder, we then will select scatter or dot, and we're going to select this first scatter plot. We're just going to drag it up there. And now you can add any two values you would like. So happiness and how much you like the university. Now notice chart preview uses example data. This is not what your chart will look like. Ours is actually going to look a lot different. And if you hit OK, up will pop a graph. Now ours looks, honestly, it looks pretty bad because we only have values, barring a few errors, that are 1s, 2s, 3s, 4s, or 5s. Interestingly though, you'll see there's nobody who had a 1 in how much they like the university, and a 1 in happiness, or a 2 in happiness, excuse me. But nonetheless, in our case, because we only have these whole numbers, it doesn't look particularly good. But you can run other correlations or other graphs and you get a much better idea of what's going on with your data. All right, so what should you be able to do at this point in time? Well, everything from previous SPSS PowerPoints. Should be able to do correlations. Should be able to write up an APA-style correlation sentence as indicated in the PowerPoint. You should be able to make a scatter plot as well. And you will also, as always, have an assignment, so make sure you check that out on Canvas.